This video is for section 4.3, Distinguishing Between Atoms. It's part one of two videos. The learning goals are to be able to know what makes one element different from another and know how isotopes of an element are different. Let's take some notes on that first learning goal. What makes one element different from another element? Elements are different because they contain different numbers of protons. A vocabulary word is atomic number. The atomic number of an element is the number of protons in the nucleus of an atom of that element. Let's take a look at some examples. Use a periodic table to determine the atomic number of neon, which is Ne on the periodic table. Well, if we pull a periodic table onto the screen and locate the element neon, which is over here on the right side, you'll notice the number 10 in that box. That is the atomic number of neon. That means that one atom of neon has 10 protons in its nucleus. Problem number 2. How many protons are in the nucleus of a carbon atom? The connection between protons and the periodic table is that it's the atomic number that tells you the number of protons. So let's pull the periodic table on screen again and locate the element carbon, which is right here. And taking a look at that number, we see it's a 6. The atomic number of carbon is 6, and so an atom of carbon has 6 protons. Not only will the atoms of different elements have a different number of protons, but they will differ in the size of their nuclei. Here's another vocabulary word, mass number. Mass number is the total number of protons and neutrons in the nucleus of an atom of an element. Let's take a look back at the two examples that we did. Let's look at our two examples again. The atomic number of neon is 10, meaning there are 10 protons. If an atom of neon also happened to have 9 neutrons, then its mass number is 19. Let's take a look at carbon. An atom of carbon has 6 protons. If it also happened to have 7 neutrons, then its mass number is 6 plus 7, or 13. Here are some check for understanding questions. I'll pause the video for you to answer these two questions, and then we'll discuss them before continuing with the lesson. Let's move on to the next learning goal. Know how isotopes of an element are different. Isotopes are atoms of the same element that have different numbers of neutrons in their nuclei. Let's take a look at some examples. Carbon-12 and carbon-13 are names of isotopes of carbon. The question is, how many protons and neutrons are in an atom of each isotope? Let's take a look first at carbon-12. When you look at the periodic table, carbon is atomic number 6. That tells us it will have 6 protons. The abbreviation for proton is a P with a little plus sign in the corner. Whenever you see that abbreviation, it represents the word protons. If the isotope is named carbon-12, then the number 12 is its mass number. That's the sum of the protons plus the neutrons. So 6 protons plus how many neutrons would make 12? That would mean 6 neutrons. The symbol that represents the word neutrons is the letter N with a 0 in the upper corner. Now let's take a look at the next isotope, carbon-13, and answer the same question. How many protons does it have? Well, all carbon atoms have 6 protons because the atomic number on the periodic table is 6. But this isotope of carbon will have 7 neutrons because the number of protons plus neutrons must add up to the mass number of 13. Let's take a look at this next example. Here we see some notation used to show an isotope instead of writing out the name of the isotope with a word and a number. Cl is the symbol for the element chlorine. So this is a particular isotope of chlorine. The top number, called a superscript, gives the mass number. The bottom number tells us the atomic number of chlorine, 17. That's the same number you would see on the periodic table if you looked up the symbol Cl. This method of writing an isotope gives more information than when it's written out in words. The question that we're asked is the same: how many protons and neutrons are there? So taking a look at this first isotope of chlorine, using the bottom number called a subscript, we can see there are 17 protons. 17 plus what number would make 35? That means there are 18 neutrons. Now let's go over to this other isotope of chlorine, which has a larger mass number. It's heavier. It has to have more neutrons in its nucleus. But notice how the bottom number is the same, 17, because all atoms of chlorine have 17 protons. So this one has 17 protons, but 20 neutrons. 17 plus 20 adds up to the mass number 37. In chemistry this year, we'll encounter different isotopes of elements. You need to be familiar with isotopes given using a name and a number, as well as isotopes that are given using this sort of notation. Here are some check for understanding questions. I'll pause the video for you to answer these on your paper, and then we'll discuss them. This concludes our first lesson for section 4.3.